What's up, guys? This is Coach Campbell again. I am here to help you guys through the Test 1 review and hopefully get you guys a little more insight on how to do this stuff. Okay? So, inquiry and scientific method. Remember, sorry, it's passing period right now. Remember, there's a test on Tuesday. Okay? So, number 1 is asking us to arrange the following links from largest to smallest, right? So, whichever one's the biggest to the smallest. And then we're going to show our work. Okay, so what we're going to do here is we're going to pick a unit of measure to rewrite all of these in. And once we have them all in the same unit, then we can just look at which number is the biggest, which one's the smallest, right? Because right now we can't just find the biggest number. There it is, 632, and assume that's the largest measurement because maybe 35 inches is more than 632 millimeters. So we have to convert them all to be in the same unit. And I think the easiest way to do that is to say, let's convert them all to meters. Okay, so we're going to put blank meters. That's what we're going to do. Excuse me while I do something quick. All right, I had to remove that sticky green pad from underneath the paper. But anyways, let's continue. Now, I let my class choose which one that they wanted to see. And some of them wanted to see letter A and some of them wanted to see letter B, right? Obviously, C is already in meters, so we can just rewrite that 1.1. And letter D is in 2 feet. So let's go ahead and look at letter B because I think that's a better one to see. And hopefully I won't lose you on trying to understand this, but it gives us 35 inches. 35 inches, right? And we want to multiply that by some sort of a conversion factor to give us our answer, and we want to convert inches into feet. So we're going to say 35 inches is blank feet, right? Now remember, whenever we're using conversion factors, we want to change inches to feet. So if we want feet, then on our conversion ratio, feet will be on top, inches therefore will be on bottom. Now, this table does not have feet to inches, but hopefully we all know that 1 foot, so I'm going to put 1 with foot, 1 foot equals 12 inches. Okay, so what we're going to do now is multiply 35 times 1 over 12, and we'll get our answer. Okay, and now I've written it on I've typed it into my calculator on my phone here, and we get 2.9166667, right? But we're going to notice that we're only given 2 sig figs. Oh man, you're not focused anymore. Okay, we're only given 2 sig figs, 35. That's 2 significant figures, which means I'm just going to convert this long, big string of numbers into 2 digits, 2 significant digits, which is 2.9. It's going to round to feet. Okay, now that we're in feet, I can now use this conversion ratio right here, right? I can use this one to convert from feet to meters. So I'm going to use that conversion ratio. I don't necessarily know if it's in the correct form yet. Maybe it is, maybe it isn't. And whatever I get, I want to convert from feet to meters. So, right, meters we want to be on top, therefore, of the conversion ratio, and feet will be on bottom. Excuse my, no, excuse somebody's rolling through a cart right now. It's all right. You're good. So feet into meters, we know that from this conversion factor, it shows us that 1 meter goes with 3.3 feet, right? And then we're going to multiply 2.9 times 1 over 3.3. Okay, so let's see that. 2.9 times 1 divide 3.3. You could also just hit 2.9 divide 3.3 and you'll get the same answer. And we get 0.87878787, right? But we said we want to round to 2 digits because that's all we're given. So we're going to have 0.87, and now this 8 is either going to round up or down. And we know that 5 and up is going to round up. 4 and below will round down. We've got an 8, which is going to round that 7 to an 8. So So you get 0.88 meters, right? Very good. Okay, I'm going to set you up with problem A. Oh, sorry, we can now put 0.88 in the 35 inches spot. Okay, 0.88. Okay. Anyways, now we can look at part A. I'll get you guys set up. So 632 millimeters. Notice your decimal is right here. And if we look at our King Henry died by drinking chocolate milk, realize that we're in millimeters, which is M, and we want to go into meters, right? And meters is going to be our base. Our base is going to be if we have like meters, grams, liters. These are going to be like kilograms, kilometers, kiloliters, hectograms, hectometers, hectoliters, etc. Right? So base is just the unit by itself. No letter leading that unit. Okay. So anyways, we've got 6.32 millimeters. We're going from millimeters and we want to get to meter. So what you're going to do is you're going to count how many hops does it take to go over to the base and in what direction. And then you're just going to follow by hopping that many digits over right here with the decimal. Okay, and that's going to convert that into however many meters that you've got, right? All right, and part D, I'll help you get set up too. Remember that you're converting 2 feet times whatever conversion ratio factor, right? Conversion factor, and your answer is going to end up in meters. And it should look quite similar to if I just covered this section. Okay, so I'll let you do that. Let's go. I'm going to move down to number 2. You can pause the video at any time and work the rest out yourself. Number 2, it wants us to arrange the following times from largest to smallest and show your work. So I asked my class today, what unit might they want to change all of these into so that they're all the same, right? We want them all to be the same, just like before, so that we can arrange them easier. And a lot of them chose minutes. Some of them chose hours. None of them chose seconds. And I found that interesting because I think that it'll be easiest to convert everything into seconds, which is what I did. So I'm gonna show you that way. Changing all of these into seconds, I found where I think will be the easiest. In this way, we're going to be multiplying everything because all these numbers are going to be getting larger. If we try to convert stuff to hours, things are going to get smaller and things are going to get messy and jarbled with all the division. But anyways, let's go ahead and identify some of the conversion ratios that are going to apply here. Okay, so I want to create a couple more boxes down here on the right. And if we look at that, we're going to want to convert seconds to minutes. We're going to want to convert seconds to hours. And we're going to want to convert seconds to days. So we know that 1 minute, if you're thinking at home, 1 minute is how many seconds, right? Well, we all know that 1 minute is 60 seconds. 1 hour converting into seconds. Well, that one might be a little bit more tricky. But we do know that 1 hour is 60 minutes. And there are 60 seconds in each minute. 60 times 60 is going to give us 3,600. So we have 3,600 seconds are in 1 hour. Okay, I'm going to move over the paper a little bit so y'all can see. All right. And the last one is converting days into seconds. So you might ask yourself, how many seconds are in a day and how do I find out? Well, you could use Google or you could use some thinking, right? So you have how many hours are in one day, and you'll say 24. So you have 24, and you're going to multiply how many seconds are in an hour, 3,600. Okay, so if we do that, we get 86,400, right? Very good. Okay, so we've got our conversion ratios here, our conversion factors. And of course, this first one is 1,500 because we're already in the same unit. Hopefully your OCD wasn't ticking, and I just filled that in there for you. So the next one is 500 minutes, 2 hours, and 0.01 days. Now, once more, I did the same problem with my in-person class, and I let them choose which one do y'all want to see, A, B, C, or D, and they chose letter D. So we'll go through letter D. Okay, so letter D wants us to convert 0.01 days into what's our unit that we want, right? Seconds. Good. So now we write our conversion factor. Days, we want to convert to seconds. So which one of these conversion factors are we going to choose? Well, you should probably pick the days to seconds conversion factor, right? So if we pick this one, what do we want to be on top? Remember that if we want a unit in the end, then that unit should be on the top. So seconds will be on the top. Days will be on the bottom. 86,400. Okay, there it is. And we're good. So 0.01 days, we're going to multiply by 86,400 and divide 1, it'll give us 864. You don't need the calculator for that. You just move the decimal twice to the left, right? And that's it. 864 seconds. Okay, so we'll write that here. And you'll continue on. Best of luck. I'm going to move on down to number 3. Okay, so on number 3, I once more asked, which one do y'all want to see? I'll show y'all one. It wants us to find out which of the following is not equivalent to 12.7 centimeters. One of my classes picked A, and the other class picked D. So I'll go with, flip a coin, I'll go with D, right? So we want to convert 1.27 times 10 to the negative 4th kilometers into centimeters. Centimeters is what we want to convert. So 1.27 times 10 to the negative 4 km. What I'm going to do first is I'm going to look at, 10 to the negative 4. That's going to tell me to take this 1.27 and move the decimal negative direction, which is left, 1, 2, 3, and 4. Replace my decimal there and add some zeros where the humps went. So I get 0.1230 and a 127. Okay, so I rewrote that number, and my unit hasn't changed. My unit is kilometers. Okay, well, my unit's kilometers, but I want the unit to be in centimeters, right? Because we're trying to see if it's equivalent here. So centimeters, how many centimeters are there in 0.000127 kilometers? Well, in order to determine that, let's go ahead and go back up over here into the top and realize that we're moving from kilometers to centimeters. So let's count. I'll do this one with you. 1, that's 2 hops. 3 hops to base, 4 hops to deci, 5 hops to centimeters, and we went 5 hops to the right. So again here, 5 hops to the right, once, twice, 3 times, 4 times, and that's 5 times. Will leave us right there between the 2 and the 7. So I have 12.7 centimeters. Now, is that the same? 12.7? That's 12.7? Yes, they are the same. Okay. So it's saying which one is not equivalent. Well, D is equivalent, so it can't be that one. So we can mark that one off. Okay, and you'll do the other three. Number 4, I also went through. I said, which one do y'all want to see? This one on the left or this one on the right? And you might imagine they picked the one on the right. It's saying which is longer, 1.23 millimeters or 2.34 times 10 to the 5th Okay, well, in order to determine that, we need to figure out which unit we want to put them both in. And I think it'll be easier, judging by this conversion factor that we're given, it'll be easier to convert stuff to meters, right? Because we have to meters. So I'm going to go ahead and write this number, 2.34 times 10 to the 5th. And I am going to write it as times some sort of a conversion ratio factor. Okay. And I'm going to say that that's going to be equal to so many meters. Okay. All right. Well, if we're looking over here, we see that 1 million is 1 meter. And you might think, what do we want to be on top? We started with and we want to go to just m. Remember that the one we want should always be on top. 1 meter is 1 million Now, it does say 1 million over here. And there is a different way that we can write 1 million, which would be 10 to the power of 6. I think that it's going to be easier writing it like this. It's going to save us some space. Okay. So we want to figure that out. How many meters is that? Right? So what I'm going to do is I'm going to write this 2.34 times 10 to the 5th. And then we're also going to multiply 1 over 10 to the 6th. Well, instead of multiplying 1 over 10 to the 6th, we could just divide 10 to the 6th, which would be the same as multiplying 10 to the negative 6. So 2.34 times 10 to the 5th. I'm going to zoom you guys in real quick. Oh, no. All right, let's see if that will work. Hopefully, yes. Had to get a little cramped there. There you go. So 2.34 times 10 to the 5th times 10 to the negative 6. That's going to give us 2.34 times 10. And we know that if we multiply same bases, we're looking at the exponents, you would just add them. Well, 5 plus negative 6 is negative 1. And our unit, well, we already converted to meters, so we're good. And we realize that that negative 1 just tells us to move over the decimal once. So that's 0.234 meters. And that would be our answer right there. Okay. Not our answer. That's half of our problem, right? Now you got to convert this one. I'm going to let you guys do that one. Hopefully I got all of that on camera. But if not, I'll leave it here for a bit. You can pause it. Go ahead and pause it if you like. And now I am going to look to number 5. Which of the following 3 questions can be answered by science and why? Okay, so remember, what does it take in order to consider something to be science? And you might recall that it requires that to be able, it requires the ability for it to be tested. So you'll look through those and describe why. Okay. And go ahead on this one. Is a scientific theory or hypothesis a more reliable explanation? And you might just find the definition. Theory versus hypothesis. I believe we talked about that on Monday. I might be wrong. It might have been Tuesday. But go ahead and flip to the back side now. And on number 7 at the top, It's wanting us. I'm going to zoom you guys out again. Hang on to your seats. Number 7. For each of the following numbers, write the number of significant figures. Then write the number in scientific notation. Remember, only significant figures go into scientific notation, and I'll touch on that whenever we're doing them. Now, I really hope you guys at home understand how significant figures work. And to kind of ensure that you do, I'm going to go through the number of significant figures on 3 of the problems. My in-person people only got 1 problem. Okay. So let's look at significant figures. 120.0. How many significant figures are there? Well, you have to remember that the rule for number of significant figures says we're going to, number 1, we're going to count all non-zero digits. So that's the 1 and the 2, obviously. Zeros are the one that kind of depend on other things, right? So maybe a sandwich, if there's a 0 on a sandwich, 406, right? That 0 is sandwiched in the middle. You always count zeros that are sandwiched. You also never count zeros that are leading zeros. They're called leading zeros because they come before the first non-zero. And the last one is trailing zeros. Trailing zeros mean they come after the last digit, kind of like this one. So we'll go through this one first. If it comes after the last non-zero digit, which is the 8 here, then you count it if there was a decimal in that number. So this one has a decimal, which means we're going to count the trailing 0. So 3, 7, 0, 8, 0. There are 1, 2, 3, 4, 5 significant figures there. Okay. Notice on this one, we have trailing zeros again. And how many significant figures do you suppose? Well, there's no decimal, so we don't count the trailing zeros. Okay? 0, 0. So 5, 0, 0, we don't count the zeros because there's no decimal and they're trailing. So we just count 1 significant figure there, the 5. 120.0. Okay, so obviously we count the 1 and the 2, and do we count those zeros? They're trailing zeros, so maybe. Remember that you only count the trailing zeros if there's a decimal anywhere in that number. And there is, it's right there. So we're going to count those 2 plus the 2 non-zeros, so we have a total of 4 significant figures. Okay. Oh, and yes, you count this one. This is also another sandwich if you caught that. Okay, 415. That's your answers. So I'll let you guys do the first one there. Remember that that's a leading 0, just like these. And we have a sandwich, and we already talked about what to do there. Okay, so what it's saying is don't forget that significant figures go into scientific notation. That just says that your scientific notation is going to include all of those significant digits. 1, 2, 0, 0. Right? So we'll do this first one. 1.200. You always write the decimal after the first significant figure. First significant figure here being 1. Times 10. And now we just got to determine the exponent there. Okay? If the exponent should be here, it's going to have to move 1, 2 to the right in order to be 120. So positive 2, 2 to the right. That's it. 1.200 times 10 to the second. Remember to write your unit, kilograms. Okay, that's it. That one's done. Okay, I'll get you guys started. This one only has 1 sig fig, so that is the 5. So you'll do 5 times 10, and you'll do that one. Remember to put the unit, which is liters. And then this last one has 5 significant figures. So that means I should be writing all 5 of those numbers. 3, 7, 0, 8, 0. Okay, where's the decimal go? I want you to try to think. Where should I put the decimal? Well, it goes after the first significant digit, which is the 3. So times 10. I'll do this one all together with you. And we want the decimal to be after the 3, but it goes once, twice, 3 times, 4 times to the left. Left in math means negative 4 hops. Negative 4 right there. Okay. Just realize if you get confused on when to be a positive, when to be a negative, realize 120 is a very big number, and this number right here is very small. Large numbers have positive exponents. Small numbers like this have very negative exponents. Okay. All right, and then Doctor Knows a Lot. I'll let y'all read that one, and then this measuring one. Well, I let my in-person people do it, but I didn't get to quite go through my measurement Nearpod with you guys like I did with them. So I am going to help you guys through this one. Okay? Or them if they choose that they wanted to come on here and watch this video as well. We're almost done, guys. Here we go. Using the correct method, determine the length of the toy car in the picture. Okay? So remember that we need to have that lined up with the 0, which it is. And over here, we've drawn our imaginary line that comes down. Okay? So our precision is based on our measuring tool, right? And we go one extra level of precision than our measuring tool is showing. So what I mean by that is we know that this car is at least 4 centimeters. Okay, we know it's at least 4 centimeters. Well, our device goes even further than that, and it says, well, it's not just 4 centimeters, it's at least 4.1, 2, 3, 4, 5, 6, 7. It's at least 7 decimals after 4, 4.7, and it tells us that. If you look here, it's just before that 8th hash. Okay, I can maybe zoom you in a little bit more. It's just before that 8th hash. And now we make our level of uncertainty guess, and you might say 4.78 or 4.79, and either one will be correct. Okay, but that's our level of judgment right there. So I'll put 4.79, and that's that. So hopefully this helped. I'm gonna, of course, post this so that y'all can see it on Google Classroom, and good luck on Tuesday's test. Remember, the test is on Tuesday. Okay, go ahead and finish this up and submit it whenever you are done onto your respective Google Classroom. Okay, how do I pause?